everyone. Now, we will going to explore about the different instruments and equipments used in meteorology. Now, have you ever wondered how meteorologists measure the speed of the wind and its impact on our weather? Today, we will explore one of the key instruments in meteorology, the anemometer. Let's dive into the history, types, and uses of this instrument. Meteorology relies on various instruments to study and predict weather patterns. Barometer measure air pressure, hygrometer track humidity, and rain gauges measure precipitation. But when it comes to understanding wind, the anemometer is an essential tool. So what is anemometer? Anemometer is a device designed to measure wind speed, and it is a common weather instrument. It is first described by Leon Battista Alberti in 1450. This simple yet powerful invention has undergone significant advancement over the centuries, becoming a staple in weather forecasting. It was divided into two classes. The first one is measures wind speed, and the second one measures the wind's pressure. The first velocity type of anemometer is the cap anemometer. It is the most common type of anemometer that was invented in 1846 by Dr. John Thomas Romney Robinson. This design features four hemispherical cups mounted on horizontal arms which spin as the wind blows. The speed of the rotation is proportional to the wind speed, providing an easy way to measure it. Although Robinson initially believed that the cups move at 1/3 of the wind speed, further experiments revealed that the ratio varies based on the size of the cups and their placement. Now, in 1926, John Patterson developed the 3-cup anemometer, which proved to be more accurate and efficient than the earlier 4-cup model. Subsequent improvements in 1935 by Prevost and Joyner reduced measurement errors to less than 3% at the high wind speeds, making this design an industry standard. While in 1991, Direct Weston added a new feature to cap anemometers by attaching a tag allowing them to measure both wind speed and direction. This innovation further enhanced the versatility of anemometers in various applications. Second type is the windmill anemometers. So this windmill anemometer is another type that is also called as propeller anemometer. In this design, the axis of rotation is parallel to the wind direction, enabling simultaneous measurements of wind speed and direction. It is often paired with the wind vane, and it provides more comprehensive data for meteorological studies. Anemometers are essential tools in meteorology and beyond. They are widely used in weather stations, wind energy research, and industrial settings, such as mining and ventilation systems. By accurately measuring wind speed and direction, they play a critical role in renewable energy studies, optimizing wind turbines placement, and ensuring safety in confined spaces. My co-presenter, Ms. Naila, will explain another type of anemometer, which is the hot wire anemometer. Until to the next video.
Hello everyone, I am Naila T Mastura and the second reporter to this group, and my part is all about hot wire anemometer, laser Doppler anemometer, and sonic anemometer. Today, we'll be discussing anemometers, devices used to measure wind speed, and let's start with hot wire anemometers, and allow me to explain how they work. What is hot wire anemometer? Hot wire anemometers use a very thin wire, often made of tungsten, heated to a temperature above the surrounding air. When an air passes this wire, it cools down, and the change in the wire's resistance, which is directly related to its temperature, is used to determine the wind speed, and the higher the wind speed, the more the wire cools, and the lower its resistance becomes. That's fascinating. So, the key is that wire's resistance changes with temperature, and this change is a direct result of a wind speed. Exactly. Hot wire anemometers are extremely sensitive and have a high frequency response, making them ideal for studying turbulent flows and rapid velocity fluctuation. There are different types of hot wire anemometers, and there are three main types of it. The first one is the constant current anemometer, the second one is the constant voltage anemometer, and the third one is the constant temperature anemometer, and each type maintains a specific variable constants which influences the voltage output of the device. For example, a CCA maintains a constant current through the wire while the CTA keeps the wire at the constant temperature. And what about the PWM anemometers? PWM anemometers use a repeating pulse of current to heat the wire up to the specific resistance, and the length of the pulse is then used to infer the velocity. They are also very sensitive and useful for measuring rapid changes in the wind speed. Let's move on to the laser Doppler anemometers and how do they work. So, laser Doppler anemometers measure the speed of particles in the flow and not the air itself. That's right. They rely on the assumption that the particles are moving at the same speed as the air. Laser Doppler anemometers are particularly useful for measuring the wind speeds in situations where hot wire anemometers might be too delicate or prone to interference. Finally, let's discuss sonic anemometers and what are their advantages and disadvantages. Sonic anemometers use ultrasonic sound waves to measure wind speed. They have a very fine temporal resolution, making them suitable for turbulence measurements. They are also very robust and can be used in harsh environments. However, they are susceptible to interference from precipitation, and the structure supporting the transducers can distort the flow, requiring the corrections based on the wind tunnel measurements. So each type of anemometer has its own unique advantages and disadvantages. The choice of which type to use depends on the specific application and the desired accuracy. Absolutely. Anemometers are essential tools for studying and understanding wind patterns, and each type offers valuable insights into different aspects of the wind behavior. So that's the end of my discussion, and the other remaining types of anemometers will be discussed by the next reporter. Thank you for watching!
Hello everyone, I am Tiffany Ann B, Bisual, your reporter for today's discussion. So today, we will talk about another types of anemometers, which are ping pong ball anemometers, pressure anemometers, plate anemometers, and tube anemometers. Let us start with ping pong ball anemometers. A common anemometer for basic use is constructed from a ping pong ball attached to a string. When the wind blows horizontally, it presses on and moves the ball. Because ping pong balls are very lightweight, they move easily in light winds. Measuring the angle between the string ball apparatus and the line normal to the ground gives an estimate of the wind speed. Also, this type of anemometer is mostly used for middle school level instruction, which most students make themselves, but a similar device was also flown on Phoenix Mars lander. That is ping pong ball anemometers. The next type of anemometer is the pressure anemometer, which means the first designs of anemometer which measure the pressure were divided into plate and tube classes. Pressure anemometers are instruments that measures wind speed and wind pressure. These are important tools for meteorologists who study weather patterns. Another type of anemometer is the plate anemometer. These are the earliest anemometers and are simply a flat suspended from the top so that the wind deflects the plate. In 1450, the Italian architect Leon Battista Alberti invented the first mechanical anemometer. In 1664, it was reinvented by Robert Hooke, who is often mistakenly considered the inventor of the first anemometer. Later versions of this form consisted of a flat plate, either square or circular, which is kept normal to the wind by a wind vane. The pressure of the wind on its face is balanced by a spring. The compression of the spring determines the actual force which the wind is exerting on the plate, and this is either read off on a suitable gauge or on a recorder. Instruments of this kind do not respond to light winds, are inaccurate for high wind readings, and are slow at responding to variable winds. Plate anemometers have been used to trigger high wind alarms on bridges. So that is plate anemometers. We also have tube anemometers. James Lind's anemometer of 1775 consisted simply of a glass U-tube containing liquid manometer with one end bent in a horizontal direction to face the wind and the other vertical end remains parallel to the wind flow. Though the Lind was not the first, but it was the most practical and best known anemometer of this type. If the wind blows into the mouth of a tube, it causes an increase of pressure on one side of the manometer. The wind open end of a vertical tube causes a little change in pressure on the other side of the manometer. The resulting liquid change in the U-tube is an indication of a wind speed. A small departure from the true direction of the wind causes large variations in the magnitude. So that's how tube manometer works. Let's proceed to the effect of density on measurements. In the tube anemometer, the pressure is measured, although the scale is usually graduated as a velocity scale. In cases where the density of the air is significantly different from the calibration value, as on high mountain or with an exceptionally low barometer, an allowance must be made. Approximately 1.5% should be added to the velocity recorded by a tube anemometer for each 1,000 feet or 5% for each kilometer above sea level.
Hello everyone, my name is Shaira A and I'm going to talk about the barometer. Barometer is what we use to measure the air pressure, and it is essentially all air pressure is the downward force of the atmosphere. And when you have a more downward force, the air pressure rises, and we have a less downward force or less weight, the air pressure drops, and that is important because typically what happens is when the air pressure is rising, the air is sinking, that is putting more pressure on the earth. But even more importantly, sinking air clears out the sky, so generally you have a nice weather, no? So when the skies are clear, the barometric is high. And when the barometric pressure falls, you have a rising air that is rising away from the surface of the earth. So the pressure that is putting on the earth goes down, the pressure falls down, and typically with low pressure, like you have a cloud, rain, extreme condition, or like thunderstorm. So the lower the pressure drop, you get the worse weather. For instance, the lower the pressure in a hurricane, the stronger the hurricane it is. So a barometer is a scientific instrument that used to measure atmospheric pressure. That is also called barometric pressure. The atmosphere is the layer of air wrapped around the earth. The air has a weight and presses against everything it touches as gravity pushes it to earth. Barometers measures this pressure. So meaning to say, it changes in the weather that are easily predicted by barometric pressure. Any change to the weather is likely to have an impact on the barometric pressure, or like short-term changes in weather can also be forecasted by meteorologists by the use of barometers. And on the other hand, a drop in atmospheric pressure is a sign of an imminent low pressure system. Here, it indicates that there isn't enough force or power to disperse stormy weather or cloud. Generally, cloudy, rainy, or windy weather is characteristic of low pressure system, and a high atmospheric pressure clears the cloud and rainy weather and cools the air, as what I have said kanina, while a rapid drop clouds the sky. Okay? So, now we have also type of barometer. The first one is the mercury barometer. It is the oldest type of barometer that is invented by the Italian physicist Evangelista Torricelli in 1643. Torricelli conducted his first barometric experiment using a tube of water. So it is a device used to measure the atmospheric pressure with a column of mercury. So in simplest form, it comprises a narrow glass tube closed at one end and open that in the other end, which is submerged in a pool of mercury. The height of the mercury in the tube changes as the atmospheric pressure changes, and the measurement of the mercury's height can in turn be calibrated to accurately measure that pressure. It is because of the mercury is toxic, it is heavily regulated, and mercury barometers are not widely available. And the second one is the aneroid barometer. In 1844, the French scientist Lucien Vidi invented the aneroid barometer. An aneroid barometer has a sealed metal chamber that expands and contracts depending on the atmospheric pressure around it. So, an aneroid barometer is an instrument used for measuring air pressure as a method does not involve the liquid. It is invented in 1845 by French scientist Lucien Vidi, and when we compare the aneroid barometer to a mercury one, we see it has a many benefits over it. In other words, it is definitely superior to it. The first one has to be quick and easy handling. As you know, mercury is quite poisonous, so there is always a risk with it. Thus, it needs a special and cautious handling. However, an aneroid barometer does not have a mercury, so one can handle it easily. Moreover, we can carry an aneroid barometer from one place to another that is easily without any worry of harm to the device. And the last one is the digital barometer. That is uses a microelectromechanical sensor to measure the pressure. Pressure sensing MEMs, or the electromechanical, are typically tiny integrated circuit which combine electronic and mechanical elements to sense the pressure. So, a digital barometer is the perfect unit for the plant lab in all other environments, where there is a need to monitor the condition of environmental air parameters. Developers and researchers are also using the smartphone's crowdsourcing that is capable to make more accurate weather forecasts. Apps like PressureNet are automatically collect that a biometric measure is from each of its user, that is creating a vast network of atmospheric data. This data network makes it easier and faster to map out the storm as they develop, especially in areas with the few weather stations. And that's all for the barometer. I hope you understand this topic, and let's look forward for the another types of the instrument or equipment that is used in meteorology.
In meteorology, knowing the height of cloud bases and the thickness of cloud layers is crucial, whether for its aviation, weather forecasting, or atmospheric research. Ceilometers are the key devices used for its importance. But what exactly is a ceilometer, and how does it work? A ceilometer is an instrument that measures the height of cloud ceilings, the base of the cloud, and can even provide insight into the cloud's overall thickness. These devices use light, often infrared, ultraviolet, or laser beams, to detect reflection from the cloud base and calculate the cloud's altitude. There are two main types of ceilometers: the scanning receiver ceilometers and the rotating transmitter ceilometer. Let's take a closer look at how each one works. First, the scanning receiver ceilometer. In this model, the light transmitter is fixed, sending a vertical beam upwards. The receiver is placed a known distance away and continuously scans the vertical beam. When the light hits the cloud base, it is reflected back. The ceilometer measures the vertical angle of the reflection and, using simple trigonometry, calculates the height of the cloud base. Next, we have the rotating transmitter ceilometer. In this design, the receiver is fixed, but the transmitter rotates, sending beams across the sky. When the transmitter's beam intersects a cloud directly above, the light is reflected back to the receiver, which then measures the height of the cloud ceiling. In modern systems, laser ceilometers are commonly used. These devices send a laser pulse vertically into the sky. The pulse interacts with particles in the atmosphere, like dust or water droplets. The device then measures the time it takes for the pulse to return, using this data to calculate the distance or height of the cloud base. Another variation is the optical drum ceilometer. It uses triangulation to determine cloud height. A rotating projector emits light at varying angles, and a fixed detector measures the return from the cloud base. By calculating the angle, the ceilometer can determine the cloud's height. While ceilometers are incredibly accurate, they are not foolproof. Laser ceilometers, in particular, can sometimes give false readings. For example, small particles in the air, like ice crystals or dust, might cause the ceilometers to mistakenly detect a cloud base even when the sky is clear. This is known issue when using ceilometers for precise cloud-based measurement. One of the most critical applications of ceilometers is at airports. Pilots rely on accurate cloud ceiling information to determine whether it's safe to fly. Ceilometers help airports monitor cloud heights in real time, ensuring safe and efficient operations, especially during poor weather conditions. From aviation safety to weather prediction, ceilometers play a vital role in observing and understanding the atmosphere. With advancements in technology, these devices continue to enhance our ability to monitor and predict weather patterns, helping us navigate the skies more safely and accurately.
Good day to each and everyone. I am Ibad Tanya A, and we're going to talk about hygrometer and its type, together with Miss Kalanduyan. So what are you waiting for? Let's go! Okay, so now let's define what is hygrometer. Hygrometer is also called as psychrometer, and it's a specialized design apparatus that calculates the relative humidity in an open area or enclosed area. So what is a relative humidity? So relative humidity is the amount of moisture in the air compared to the maximum amount of moisture the air can hold at a given temperature. It is expressed as a percentage. So the term hygrometer is formulated from the Greek word hygros, which means moist or wet. So in order to determine the relative humidity, the hygrometer makes use of wet bulb and dry bulb thermometer. A wet bulb thermometer and a dry bulb thermometer are essential tools for measuring temperature and humidity. So as you can see in the picture, on the left side is the wet bulb thermometer and on the right side is the dry bulb thermometer. So when we say dry bulb thermometer, is a standard thermometer that measures the ambient air temperature without accounting for humidity. So when we say ambient air temperature, this is the temperature of the air around you. So it's like what you see on a regular thermometer. It is the basic straightforward temperature reading. A wet bulb thermometer, on the other hand, is designed to measure the apparent temperature, which takes into account both air temperature and humidity. So when we say apparent temperature, this is how hot or cold it feels to you, taking into account both the air temperature and the humidity. For example, on a humid day, even if the air temperature isn't super high, it can feel much hotter because the humidity makes it harder for sweat to evaporate and cool you down. And also its bulb is covered with a moistened cloth, typically made of muslin, which is kept wet by wicking action from a reservoir. So as you can see in the picture, there is a muslin. So yung muslin, it allows for efficient evaporation of water in the wet bulb. So now here's the three types of hygrometer. So first type is the capacitive hygrometers, second is the high tension hygrometers, and third one is the electronic hygrometers. So first, let's talk about the capacitive hygrometers or capacitive humidity detector. Is a type of humidity sensor that utilizes the principle of capacitance to measure the amount of moisture in the air or other gases. So these capacitive hygrometers, it consists of two conductive plates separated by a hygroscopic dielectric material. So this material is typically a polymer or metal oxide that has the ability to absorb water molecules from the surrounding environment. So as you can see in the picture, yung thin film polymer, that's the hygroscopic dielectric material, and it's also called as the polymer film sandwich. So the polymer film sandwich is nag-act siya as a bridge between the two electrodes, the upper electrodes and the lower electrodes. And also, polymer film sandwich is nag-act din siya as a bridge between the humidity level in the environment and the electrical signal produced by the hygrometer. So, bearing in mind that the electrical capacitance will be higher when the dielectrics collects more water. So now let's talk about its advantage and disadvantage. So first, it's the advantage. So the linear voltage output, and it works well under a wide temperature range and maintains condensation tolerance. And it's also ideal for a long-term application. And on the other hand, its disadvantage. The distance between the humidity sensor and the signaling circuit is limited, and so this restricts its application over a large open areas. So the other types of hygrometers will be discussed by Ms. Kalanduyan.
Hi, Assalamualaikum and good morning. By the way, I am Nafla Kalanduyan and I am the 6th reporter of this group. So for today's video, I will be discussing to you the hair tension humidity sensor. Compared to the RF sensor, a more organic form of a typical humidity sensor is that of the hair tension hygrometer. This type of hygrometer uses animal hair mounted in a cluster as sensing elements. So due to that, it is keeping the hair under tension increases the sensitivity of the hair to change in humidity, temperature. Thus, a direct change in the length of the hair can be measured by using a dial or scale. So the tips of each hair are bundled together and held in a position using a screw, while the lower end of each hair is under tension. So the screw on the other hand at the top end of this hygrometer is also adjustable for the shift. Each hair to this device is approximately 200 to 300 mm in length. So any change in atmospheric temperature and humidity will change the length of each hair connected to an array of levers wired to a recording device. So in response to change in humidity, the hair expands or contracts, which is it displaces the movement of a hook. So the movement of each hair is magnified, which that magnified and it provides an accurate and linear measurement of relative humidity RH over 0 to 100%. So here are the advantages and disadvantages of hair tension humidity sensor. So the advantage of that device is that it has been popular amongst meteorological research based on the simplicity of its use, while the disadvantages of it is that it rapid changes in humidity, which is it magnified the errors recorded by the dry hair hygrometer. And of course, it also increased sensitivity to rapid changes in humidity limits, which is that limit is used in extreme environments where sudden shifts in the level of humidity are common. And of course, the hair samples here can become damaged due to continuous tension. Okay, so now let's move on to the electronic humidity sensors. So, modern day humidity sensors are based on microprocessor-based circuitry. Okay, so for example, so the dew point humidity sensor is stable and let's say it can be used over a long period of time. So the dew point here is defined as the temperature state which allows the air moisture to saturate as vapor. So there are also a working principle for this sensor which involves a mirror surface and
optoelectronics to measure the amount of water vapor on the surface of the mirror. So the temperature to this mirror is electronically monitored to help measure the dew point. So there is also a monolithic circuit, and that monolithic circuit is connected to the dew point sensor, which is that dew point sensor provides an electrical wave which is proportional to Rh, and that Rh helps to calculate the vapor pressure. So here are the advantages and disadvantages. So the advantages of the electronic humidity sensor: it is durable and of course resistant to chemical vapors, and of course it can be applied in extreme temperature environments, example 575 Fahrenheit. And of course, you can also make a direct comparison of a dew point measurement and the relative temperature of material. And the disadvantage of this naman is the gases with thermal properties will obscure the overall reading on humidity sensor lines, including the Honeywell and the Sensirion. Okay, so now let's proceed to the application for humidity sensors. So the humidity sensors have a wide range of applications, such as food processing industry. Yes, example, incubators for eggs. So we are very familiar with that. Second one is the social health settings, such as sauna. Coating industry with the quality of paint needs to be controlled due to it being sensitive to dew point conditions. Meteorological research, and of course, the environmental monitoring. So for example, the environmental monitoring is used to help restore environmentally sensitive rainforests. Another is automotive onboard devices, example, the windshield defoggers, and of course, medical, example, the ventilator and incubator. So it is also very familiar. And of course, consumer electronics. And lastly, the building technology. So example, building cavity wall insulation. So that would be all. Thank you for watching.
Anemometer, barometer, ceilometer, hygrometer, pyranometer, and etc. are the instruments and equipments used in meteorology. But let's focus in one instrument, which is the pyranometer. Assalamualaikum, I am Ladsak and I'm going to explain what is pyranometer. Have you ever wondered how scientists measure sunlight? Meet pyranometer, a key instrument in meteorology used to measure solar radiation. So, let's dive into what it is, how it works, and why it is important. So what is pyranometer? A pyranometer is a type of actinometer that can measure solar irradiance in the desired location and solar radiation flux density. So the solar radiation spectrum extends approximately between 300 and 2,800 nanometer. The pyranometer only requires a flat spectral sensitivity to help cover the spectrum. So, ang pyranometer ay isang instrument na ginagamit upang sukatin ang dami ng energy na galing sa liwanag ng araw o solar radiation flux density. So, this data is essential siya across various industries, including renewable energy, constructions, and meteorology. So we have here the two design of pyranometers. The first one is thermopile, a sensor consisting of thermocouples connected in series and provided with a black coating for absorbing all solar radiations. And the second one is glass dome. This dome restricts the spectral response from 300 to 2,800 nanometer from a field of view of 180 degrees. So this hemispherical glass dome also shields the thermopile from wind, rain, and convection. And the other one is the occulting disc. It is used for measuring the diffuse radiation and blocking beam radiation from the surface. So how does pyranometer work? The pyranometer works by using a black-coated sensor that absorbs sunlight. The sensor converts the absorbed radiation into an electrical signal. So this signal is then recorded and used to calculate the solar energy received per unit area. So the glass dome helps protect the sensor and ensure accurate measurements by preventing wind and dirt interference while also capturing light from every angle. So these are the advantages. The key benefits of pyranometers are listed below. So first is very small temperature coefficient. Second one is calibrated to ISO standards. The third one is more accurate measurements of performance index and performance ratio, and longer response time than a photovoltaic cell. So the following are the major applications of pyranometers. First is predicting insulation requirements for building structures. So sinusukat nito ang dami ng energy na kailangan to maintain proper temperature in buildings. Then, the second one is establishment of greenhouse locations. So, ang pyranometers data is nag-help siya to identify optimal locations for greenhouses to maximize sunlight exposure. And the third one is designing photovoltaic system. So, dito, ang data na nanggagaling sa pyranometers is essential in optimizing photovoltaic systems for better efficiency. Then, the fourth one is meteorological and climatological studies. So, dito ang pyranometers is crucial in meteorology and climatology research. Then, the last one is measurement of solar intensity data. So, dito ang pyranometer is used in renewable energy projects and scientific studies that require precise solar energy measurements.
Good day. My name is Norhana U Oyong and I will be the one to discuss the rain gauge. So first, let's dive into our introduction to understand what is rain gauge and what are its functions. So rain gauge is a meteorological instrument to measure the precipitating rain in a given amount of time per unit area. So basically, it is an instrument to measure the rain in a given time. For example, in this specific area like Cotabato City, this instrument is used to know how many rain is being dropped in, like for example, in 1 minute. This instrument consists of a collection container which is placed in an open area. And this precipitation is measured in terms of the height of the precipitated water accumulated in the container per given time and is expressed in millimeters. Since the same amount of rain precipitation is assumed to be occurring around the container, the area of collection is not a factor. However, it shouldn't be too small, neither should it be too large. Due to spatial uniformity of rainfall, 1 millimeter of measured precipitation is the equivalent of 1 liter of precipitated rainwater volume per meter squared. Again, rain gauges is a type of instrument used by meteorologists and hydrologists to measure rainfall rate in a certain period of time. And rain gauges are also known as odometer, pluviometer, and ombrometer. So there are two types of rain gauges, which are the non-recording type and the recording type. So first is the non-recording rain gauges, and it is most common type of rain gauges used by meteorological department. It consists of a cylindrical vessel in 127 millimeter in a diameter with a base enlarged to 210 millimeter diameter. Example of this is the Simon's rain gauge. So this figure is the Simon's rain gauge, and this is what it looks like. Note that this type of rain gauge is a non-recording, so basically it is a manual checking rain gauge, so you need to check it every day or day by day to gather data. So the second type of rain gauge is the recording rain gauge. If we have a non-recording we also have a recording. So from the word itself, recording means it records data automatically, so you don't have to check it day by day. So I have here 3 types of recording rain gauge. So first is the weighing bucket type of rain gauge. This type of rain gauge is most common self-recording rain gauge. It consists of a receiver bucket supported by a spring or lever balance or some other weighing mechanisms. The movement of bucket, due to its increasing weight, is transmitted to a pen which traces record or some marking on a clock-driven chart. So this figure is the weighing bucket type of rain gauge. So second is the tipping bucket type of rain gauge. So this type of rain gauge is a 30 cm size circular rain gauge adapted for use by US Weather Bureau. It has 30 cm diameter sharp-edged receiver, and at the end of the receiver is provided a funnel. And this figure is the tipping bucket type of rain gauge. And the last type of recording rain gauge is the floating or natural siphon type of rain gauge. So the working of this rain gauge is similar to weighing bucket rain gauge. A funnel receives the water which is collected in a rectangular container, and a float is provided at the bottom of container, and this float rises as the water level rises in the container. So it's moving, being recorded by a pen, moving on a recording drum actuated by a clockwork. And this is what it looks like. So that's all for my part. I hope you learned something, and thank you for listening.
Good day everyone, I am Saadra Dimalna, and today we are going to tackle about the weather balloons. So what is weather balloons? Weather balloons are used to gather information about atmospheric conditions, primarily in the upper atmosphere. This information is vital for weather forecasting and understanding atmospheric processes. The balloon carry instrument allow to measure these conditions. Weather balloons are inflated with helium, a gas less dense than air. This lower density is what provide the buoyancy needed for balloons to ascend to high altitudes, carrying their instrument into the upper atmosphere. These weather balloons carry instrument called radioson, which measures various atmospheric parameters including temperature, air pressure, humidity, and GPS location, where wind speed and altitude are calculated. How does weather balloons work? Weather balloons play a crucial role in meteorology by providing direct measurements of atmospheric conditions at various altitudes. Here's how they work. First, inflation and launch. A large lightweight balloon, often teardrop-shaped balloon, is inflated with helium. Helium's lower density than air provides the buoyancy needed to lift the balloons and its attached instruments. The balloon is then launched from a ground station. Number 2. Ascent and data collection. As the balloon ascends, it carries a package of instruments called radioson. This radioson measures various atmospheric parameters including temperature by using a thermistor, pressure by using a barometer, humidity by using hygrometer, wind speed and direction often determined by tracking the balloon's movement using radar or GPS. Number 3. Data transmission. The radioson transmits the collected data wirelessly back to the ground station in real time. This data is then used by meteorologists to create weather models and forecasts. Number 4. Burst and instrument recovery. The balloon continues to ascend until the pressure difference between the inside and outside of the balloon causes it to burst at a high altitude, typically around 90,000 feet. A small parachute is deployed to allow for a safe descent of the radisson, which can then be recovered and reused. And the last, number 5, data analysis and forecasting. The data transmitted by the radisson provides a vertical profile of the atmosphere, offering valuable information on temperature, pressure, humidity, and wind at various altitudes. This data is integrated into sophisticated computer models used for weather forecasting. There are types of weather balloons. The number 1 is the pilot balloons. Pilot balloons are small balloons used to visually track wind speed and direction at different altitudes. Number 2, sailing balloons. Sailing balloons are used to determine the altitude of the cloud bases. Number 3 is the teardrop-shaped balloons, or this is the standard weather balloons. It is the larger teardrop-shaped balloons that carry radisson to measure and transmit atmospheric pressure, temperature, and humidity. And the last one is the tetrahedral balloons. Tetrons or tetrahedral balloons are developed for horizontal sounding and designed to withstand the extreme low pressure of high altitude flight. That's all. I hope you learned something. Bye!
Hi! Good morning to each and everyone. I am Jamillen P. Datumanong, and today we will know about the weather satellites and its importance.
A weather satellite is a spacecraft specifically designed to monitor Earth's atmosphere and surface to collect data for weather observation, forecasting, and climate analysis. These satellites are equipped with advanced sensors and cameras that capture images and measure various environmental parameters such as cloud cover, temperature, wind speed and direction, humidity, ocean currents, and sea surface temperatures. This is how looks a satellite moves above the planets. So there are 2 types of weather satellites. First is geostationary satellites. The second one is the polar orbiting satellites.
Geostationary satellite is stationary relative to the Earth. That is, it moves above the equator at the same rate as the Earth rotations, so that all the time it is above the same geographical area on the Earth. In this manner, it is capable of taking cloud images of the same area continuously 24 hours a day. It is capable of taking cloud pictures covering part of the globe.
While polar orbiting satellites are low-flying satellites circling the Earth in a nearly north and south orbit at several hundred kilometers above the Earth. Most of them pass over the same place a couple of times a day. As they operate at distance closer to the Earth, they are only capable of taking cloud images of a limited area of the Earth each time. Compared with geostationary satellites, polar orbiting satellites offer fewer and smaller cloud pictures. However, the advantage is that the cloud pictures obtained are of much higher resolution.
In conclusion, weather satellites are indispensable tools for modern meteorology, disaster management, and climate monitoring.
Good morning, everyone. I am the last reporter from the Group 3. I am Nhorhasmin R. My assigned topic is about weather radar. And so, ano nga ba ang weather radar? So, what is weather radar? Weather radar is an instrument used to locate precipitation, calculate its motion, intensity, and determine the type of rain, snow, hail, or etc. So weather radar sends out a pulse of electromagnetic energy into the atmosphere. If the piece of energy interact with something in the environment, it will reflect energy back to the weather radar and we can sense it. So today, most radar use the Doppler effect and have dual polarization. So to add a Doppler radar determines whether movement is toward or away from the radar. So gumagana ito sa pamamagitan ng Doppler effect kung saan nagbabago ang frequency ng electromagnetic waves depende sa direction ng galaw ng mga bagay na tumatama dito. Kung ang ulan o hangin ay gumagalaw o papalapit sa radar, tataas ang frequency ng signal na babalik. Kung ito naman ay papalayo, bababa ang frequency. So, sa ganitong paraan, nalalaman kung papalapit o papalayo ang galaw ng ulan, hangin at iba pang mga bagay sa atmosphere. So, dual polarization is a combination of radar design and software algorithms that help identify the types of precipitation. So, ang radar ay gumagamit ng dalawang uri ng signal. Ito yung horizontal at ang isa is vertical na alon na electromagnetic waves. Ang kakayahang magpadala at tumanggap ng mga signal sa parehong direction ay nagbibigay ng mas detailed yung impormasyon tungkol sa anyo, sukat at uri ng mga batak ng ulan. So, tulad ng ulan at snow, no? Ang mga algorithm naman ay ginagamit upang maproseso ang data na ito at mabigyan ng tumpak na analysis tungkol sa mga kondisyon ng panahon. So, radars have 4 basic components. So, number 1 is transmitter, which generate the energy pulse. So, ang pulse na ito ay pinapadala sa atmosphere upang ma-reflect sa mga bagay na natagpuan doon tulad ng ulan, yelo o iba pang mga objects. No? So, number 2 is an antenna to send this pulse out into the atmosphere and receive the reflected pulse back. No? And the third is a receiver which detect and amplify the signal. So, ito naman ang receiver ay tumatanggap at nagpapalakas ng signal na galing sa antena. Kapag ang signal ay bumalik mula sa mga object, tinitiyak ng receiver na may sapat na lakas ang signal upang maproseso ito ng radar. No? So, the last is the display system. So, ito naman ay nagpapakita ng impormasyon na nakuha ng radar. Ipinapakita nito ang lokasyon ng mga object tulad ng mga ulap o iba pang bagay sa atmosphere at nagbibigay ng mga detalye na ginagamit ng mga meteorologists upang magsagawa ng tumpak na weather forecasting. Benefits of weather radar. So, weather radar is an integral part of modern weather observation system. So, weather radar support operation of National Meteorological Institutes. So, tumutulong ang mga weather radar sa mga meteorologists na mag-monitor at mag-predict ng mga condition ng panahon. Pinapayagan nito ang mga expert na tuklasin ng mga ulap, bagyo at iba pang meteorological na phenomena. Second, hydrological service. So, mahalaga ang weather radar sa pagtukoy ng mga pag-ulan at iba pang kondisyon ng panahon na may epekto sa mga ilog, lawa at iba pang water bodies. So, makakatulong ito sa mga hydrologists na mag-monitor ng pagbaha, pagplano ng mga hakbang pang prevention o solusyon sa mga natural na sakuna. So, the fourth is aviation authorities. Dito is mahalaga din ang weather radar para sa kaligtasan ng mga eroplano. So, binibigyan nito ang mga piloto at air traffic controller ng impormasyon tungkol sa mga bagyo, malalakas na ulan, o mga kondisyon ng panahon na maaaring makaapekto sa flight. So, ito ay tumutulong para maiwasan ang mga panganib at matiyak na ligtas yung biyahe. And the last is various other applications. Ang weather radar ay ginagamit din sa iba pang larangan tulad ng agriculture, construction at pagtugon sa kalamidad. So, halimbawa, ginagamit ito pang masubaybayan ng mga kondisyon ng panahon na magkakaapekto sa mga pananim o proyekto sa construction. At magbibigay ng alerto sa mga lugar na maaring tamaan ng malalakas na bagyo o baha. Yan lang po.